This video is about constitutional isomers. Constitutional isomers are those that have the same molecular formula, but have different connectivity and therefore different structures. So again, these are molecules that both have the same molecular formula, but they have different connectivity of those atoms. And so that can lead to very different properties. For example, C4H10 has two different constitutional isomers. So the same molecular formula, but different structures. So you can have the four carbons all bonded together in a linear row. The straight chain, we'll call it. So it would just be 1, 2, 3, 4 carbons. With the line angle notation, you would just have 1, 2, 3, 4 carbons or 3 lines. 1, 2, 3, 4 points and 3 lines for the line angle notation. But let's say that you tried to take a carbon off the end of the chain and instead you made it as a branch coming off of the middle carbon. That's a new molecule that's going to have, for example, a lower boiling point because of that branch in the chain. It's going to have different properties. And so that would be a constitutional isomer. Its line angle formula looks different. It's got 2 lines for the 3 carbons in a row, and off of the middle is a branch, and so it kind of looks like a Y almost, where you have your 3 carbons in a row along the top of the Y and your carbon coming straight down, making that sort of base or trunk of the Y. What about C5H12? Well, again, you can have this straight chain, 5 carbons all in a row. So you would have 4 lines in your line angle, 1, 2, 3, 4, 5 total carbons. But again, you could take one of these off the end, and then if you had 4 carbons in a row, you could put a carbon coming off of the second carbon and have a branch. And so again, you could draw that those 4 carbons in a row as 3 lines, and then you could do a branch coming off of the second carbon, a CH3 branch. If you filled everything in, you'd have CH3, CH, CH2, CH3, and then you have the CH3 branch off the second carbon. Now, sometimes people will say, well, why can't you just take those 4 carbons in a row? Instead of putting the branch on the second carbon from the left, why don't you put it on the second carbon from the right? Well, those are actually the same structure. They're just a mirror image of each other, and in this case, those 2 mirror images are exactly the same. You could just flip it and turn it over on itself, and it would be the exact same. But there is one more constitutional isomer, and that is if you take a carbon off of the end of the chain, so you had 4 carbons in a row, you have a branch or a carbon group coming off the second chain. If you take it from the farthest one on your right, or the longest main chain, you'll have 3 carbons in a row. You would have a branch on the middle carbon, and the one you took off the end, put it on the middle as well, one coming up and one coming down. So essentially you have a carbon in the middle with 4 methyls around it. In all of these cases, the molecular formula is the same, C5H12, but the structure is very different. You have no branches, straight chain, you have 1 branch, and you have 2 branches. And these will have very different properties. For example, with every branch, we'll see a lowering of melting and boiling points. 1 branch will lower it some, a second branch will lower it more. And so these are brand new molecules with different properties. So constitutional isomers are molecules with the same molecular formula, but a different connectivity of the atoms. Oftentimes they have branches, for example, on the parent chain.